We are working our way through section 6.2, the right angle triangle. We're going to get that finished today, and we'll start the next one. What I thought I would do today is go back to this little table here, because we're going to use it in some other questions, but I'm going to add to it. Remember, this table was for the 30, the 45, and the 60 degree, and the three major trigs, the sine, cosine, and tangent. You will sometimes get questions where you need to know the exact value of radians rather than degrees. So can anyone tell me what pi, what version of pi? What is 30 degrees in radians? What fraction is 30 degrees as radians? Any takers? You could do a quick correction. I'm going to write it if I don't get one.
Is it pi over 6?
You nailed it. It is. What's 45 degrees in radians? Pi upon what? 45 degrees.
I got 5 pi over 12.
Nope. Not for 40.
Right. Yeah.
That's something else, but it's not that one. Last chance. Pi upon what is 45 degrees?
4.
Right. And 60 degrees, the last one, pi upon what?
3.
Yes. So sometimes you're going to find the sine of 30, but sometimes you're going to find the sine of pi upon 6. Now this one, if you've got the table handy, is going to go quick. Otherwise, you're going to look at those little triangles and come up with them. What's the sine of 30 degrees? Exact value, sine of 30 degrees.
1/2.
Correct. This one is root 2 upon 2, and this is root 3 upon 2. Okay, what's the cosine of 30 degrees?
Square root of 3 over 2.
This is root 2 over 2, and this is 1/2. Do you notice that these are the same guys but switch places? Right. What's the tangent? Tangent of 30 degrees. Anybody? Tangent at 30 degrees. Last chance.
Root 3 over 2.
Oh, almost. Root 3 over 3.
Oh.
And this guy here?
That should be, wasn't that root 3?
Well, and this guy is root 3 over 3. Which is 1 over.
Yeah, it's backwards.
No, let me get that there. I got that backwards. Damn it, space. This is 1 over root 3. And 1 over root 3 gets you root 3 over 3. And this guy gets you just root 3. So,
yeah.
Sorry about the mess. I've talked myself out of the right answer. Right, we're going to use these guys. First group of questions are pretty much just using these guys to get exact values for some calculations. So the one I'm looking at right now, and I'm only going to do a few more of these, is one that's similar to question 12. And we're being asked to find the exact value for the sine of pi upon 3, cosine of pi upon 4, take away the sine of pi upon 3 times the cosine, sine of pi upon 4, followed by the cosine of pi upon 3, and that whole thing is going to be squared. So each one of these I'll get from this table. So pi upon 3 is here. So if I want the sine, it's that guy. And if I want the cosine, it's that guy. I want the sine of pi upon 4. Here we go. Is that guy. And I want the cosine of pi upon 3, which is that guy, which is a half. And then I'm going to square it. And multiply them together, you get square root of 6 over 4. And if you multiply these together, you get square root of 2 over 4. And the whole thing's going to be squared. Now we're going to show you something that I think a few of you have been doing wrong from what I can tell. And you're going to look at that and say, oh, that's dead easy. It's just that guy squared, right? Take away that guy squared. But that's not, in fact, what you get if you multiply this out. It's more complicated than that. It's actually FOIL. And that means that you're going to have more than just these two terms. Right? If you do the first, you get that guy. But then you also get this fella. And this guy times this guy is negative square root of 6 over 4 times square root of 2 over 4. And then if you do the inside, which is that one, you get negative square root of 2 over 4 times square root of 6 over 4. And then when you finish, you get that guy. So if I take each of these pieces, let's see what we get. This guy, if you square it, gets you 6 on the top and 16 on the bottom. This guy, if you multiply the top and bottom together, you get square root of 12 over 16. But this guy, you also get square root of 12 over 16. And this guy, if you square it, you get 2 on the top and 16 on the bottom. Now, these two get you 4 out of 16, which is a quarter. And these two go together, and it looks something like that. I'm taking a lot longer than you need in this question. Right, is there anything you can do to this to make it nicer? Because we should always simplify things if we can. Can you simplify this in any way?
Negative 1/3.
Yes, divide top and bottom by 2, and you've now got that. And that looks even better, doesn't it? A little bit nicer. But can you do anything with square root of 12, which might be what someone's about to tell me?
I was wondering how you got 6 on the bottom of the fraction instead of
16. I just made a mistake,
Oh,
which I've now fixed. But we'll cut. Right, is there anything you can do with the square root of 12?
4 times 3, so then it would be like 2 with the square root of 3.
Agreed. And so what you end up with is that. Can you see, you could spend a lot of time making this pretty. Since both of these fractions share a common denominator, would you agree it would probably make sense to put them together as one weird looking fraction? So after all that hard work, that fella ends up looking like that. Would you need every single one of these lines? I doubt it, but you put in as many lines as you need to make sure that you've got the correct answer. So far, so good. Right. I'll just do one more of these. The one I'm going to do now is a version of 14, and then we will look at some more word story puzzle questions. So in this case, it's going to be the sine of pi upon 3 times the tan of pi upon 6, take away the cosecant of pi upon 4 all squared. And this happens to be a question that a student was asking for help with earlier today. Right, the sine of pi upon 3, the sine is this guy. The tangent of pi upon 6 is this guy. This one's going to be a bit trickier. If you wanted to do the cosecant of pi upon 4, I don't have cosecants here, but if I did have a cosecant here, wouldn't it be the reciprocal of the sine? Right, the upside down version. So if the sine is this, won't the cosecant be that guy? Are we good? So this can tidy up a little bit because 2 square roots get you 3 and 6 on the bottom. But wait a minute, can't that become a half? Are you comfortable with the tidying up and the simplifying that I've done? We good with this so far? Looking for happy faces. Yeah. Take this guy and multiply him by himself. And I'm just going to do the quick version. A half times a half gets you a quarter. This times this gets you negative a half times that fella. Then you get this fella times a half. And then this guy times this guy gets you positive. 2 times 2 gets you 4, and 2 square roots get you that. So I have a quarter. They cancel out, and I have this fella. They cancel out, I have this fella. And I've got a 2. And all I'm going to do now is try and make it look nice. 2 1/4. You might call it 2 1/4, but in mathematics, we don't do mixed fractions. So I'll convert it to 9/4. That's what 2 1/4 looks like. And since these are the same, I have 2 of these guys. Do we leave fractions with square roots in the bottom in trig? No. So how do I fix this guy? What special version of 1 do I multiply it by to make it look nicer?
Root 2 over root 2.
Agree. Now that gets me negative 2 root 2 over 2. Oh, but they cancel. And would you agree that's quite a nice looking answer considering what it used to look like?
Could you move your paper up just a little bit so we can see the?
Oh yeah, on my screen I can see it, but that isn't your screen. So okay. There's a point. Do you lose it round about here?
That's where I can't see it.
Okay, so I just have to keep away from the bottom 4 lines, and that way it'll work from now on. Right? That'll work for me too. Are we happy? Oh, let's bring it back up so you can see it. Right? Are you happy with where it came from? You all feel good? Right. So we are left with some puzzle stories. They happen right at the bottom. There's to do with angles of elevation and tall buildings and all that type of question. So let me tell you where they are so that when you look at the homework, you know where to go. We are looking at questions 22. Up to question 28, right? So that's the last bunch of questions, and they involve puzzle stories, and almost always we're going to have right angle triangles, and we're interested in finding missing lengths and missing angles. So which one will I try first? Let's do a word story first. So this is question like 23. And a plane is flying within sight of the Gateway Arch in St. Louis, Missouri, an elevation of 25,000 feet. So I'm going to imagine that this is the ground, and there's my little plane. And when you tell me that you're flying at an elevation of 25,000 feet, haven't you basically told me that that number is 25,000? Then I read on a little bit later. The pilot would like to estimate her distance from here, right? She finds that the angle of depression to a point on the ground below the arch. Oh, so actually the arch is over here. And from the aircraft, what's called the angle of depression. So let me tell you how that works. Horizontal line, and you look downwards, right? That is called the angle of depression. And in this story, that angle is 19 degrees. And she would like to know how far away she is, right? And let me read this question, make sure I've got the right one. Her distance from the gateway arch. So she's actually wanting to know that distance. How far from the aircraft to there? Okay, now I'm going to take that picture and I'm going to make a right angle triangle out of it. And I can make two right angle triangles, actually, now I think about it. If I decide to do this triangle, right? The guy I'm trying to find, oops, excuse me, I've made a mistake. I get too many pictures here. I'm going to use this one. That's the one I want to use. And I know that this angle here is 19 degrees. And I know that this distance here, I was using two pictures there and they're just distracting the heck out of me, is 25,000 feet. And we are interested in that distance. So here's my aircraft and here is the arch, right? So I basically, oh, and there's my right angle. So everything I need to know is in that picture, right? Agreed? So once you've got a picture, from that angle's perspective, won't this side be called the opposite? And won't this side be called the hypotenuse? Which one of the three trig ratios uses the guy that you know and this one that you're trying to find? Uses opposite and hypotenuse.
Sine.
So you do opposite over hypotenuse. And you do the sine of 19 degrees is 25,000 divided by x. And typically I put a little 1 there because aren't you going to do a little cross multiply in a few seconds? So when I do the cross multiply, I get the sine of 19 degrees times x is 25,000. And what do I do then to find x? What do I do to both sides to find
Divide by
x?
sine.
Okay, so so 25, 1, 2, 3, divided by the sine of 19. And let me check that I'm in the right mode. I am, good. Oh, so 25, oops, clear that. That was just a really big number. 25,000 times the sine of 19. And, okay, 8,100
Isn't
and,
it division?
oh, yeah. God, I'm getting old. It's there. Third time lucky. Actually, wasn't that the answer I got the first time? Blah, blah, blah. Right. Now I'm reading the question. Oh, they want it to nearest feet. Okay, so 76,789 feet. Are we cool with that number? I want to check that answer. It seems quite large. So normally when I do questions, well, puzzle questions, I like to kind of say, okay, does that make sense? It may be correct. It just looks kind of large to me. Like that's a long distance. Guess what? That's the right answer. It just looks large to me. Okay. Now that's part A. Right? Part A was basically find this guy. Now part B was what is the distance between the point directly underneath the aircraft and that. So I'm going to call that guy Y. So the second question is find that distance there. Try and make that a little bit near. So I need a right angle triangle, don't I? If I create a right angle triangle that looks like this, that will be Y. That's a right angle. This is 25,000. Oh, don't we know this guy? 76,789, right? Because we found that already.
We technically also know all the angles too.
We do. Isn't all the angles going to be things like 19 and 71 degrees? So we probably have more information than we need. Since I've written this information down, would you agree that Pythagoras would probably be the way I would do it? Right. So I would go a squared plus b squared equals c squared, and that would be 25,000 squared plus y squared equals 76,789. And at this point, I'm going to just say dot, 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 dot. Would you agree it's just big, ugly numbers and you can get the answer? So I'm not going to dwell on the details. According to what I'm seeing in front of me, it's also huge. It's about 72,000 feet, which is quite a few miles away. Are we good? Let's do another story with words in it. And then after that, I'll do some stories that have pictures in them. I like the ones with pictures better than the ones with words. Because see, the ones with words, don't you have to draw your own picture? And I'm not the best artist in the world. So a laser beam is to be directed towards the center of the moon. Okay, there's the moon. Here's my laser beam going right to the center of the moon. Okay. But the beam strays half a degree. So basically it goes that much. And that tiny little angle in there is half a degree. Okay. Now, how far has that beam diverged from its original target when it reaches the moon? And the distance from the Earth to the moon is 240,000 miles. Right, if I drop a little vertical line down the way and another horizontal line across the way, can't I make a right angle triangle? Agreed? And I forgot what question this is. I better scroll for it. Where are you? Oh, this is question 24, or at least like it.
Well, can't
Yes.
you have that bottom side, the 0.5 degree, right?
I could have it here.
Yeah, that
Yeah.
side, right? That can be
Yeah.
the bottom.
Yeah, my
And then
picture
you
is
have
so
the
hard
two
to. Yeah, my picture is so hard to see. Oh yeah, yeah. Why am I doing curves? There we go, straight lines. Not to scale. Can I make that 0.5 of a degree? I think that makes a lot more sense.
Yeah.
You agree? Yeah. And the distance that you are diverted is basically that distance, right? That would be if it went straight, and this is half a degree off. That's much better. And now I know the distance to the moon is 240,000. So basically I know that. So that's the picture I probably should have drawn the first time. And we are trying to find that guy. In fact, now that I've set this picture up, would you agree that it's a pretty standard question? Which one of the sine, cosines, and tangents would you use to find x? Just looking at the picture. Sine, cosine.
Sine.
Right, and off you go and do it. So I'm going to do dot, dot, dot on that one. Okay. So we are now going to do some pictures. And although I am a visual learner, I can visualize things. I am hopeless at drawing. So there is a person in this story. There she is. And if she looks horizontally like that, there's a flagpole. And the flagpole is like Here's the ground. And by the way, she's on a hill, right? If you're wondering how that works. And this is the flagpole. Actually, that's not bad for me. Does that kind of look reasonable, right?
Looks decent.
It's decent. I agree. Now, she's on the hill, and then she knows, what does she know? She knows that when she looks to the top of the flagpole, that this angle here is called the angle of elevation, and she knows it's 18 degrees. And for no particular reason, except I want to, I'll make this one red. And she knows that when she looks downwards, it's 14 degrees. And what else does she know? What else does she know? There's a number in here. Oh, and she knows that the flagpole is 40 feet tall. And I'm going to shrink this because I've made it so big I can't read the right and to the left. Okay. I won't stand in the hill, see the flagpole, she knows it's 40 feet tall. Good. The angle of depression to the bottom is 14 degrees and the angle of elevation to the top is 18. Find her distance x from the pole. So we are being asked to find that distance there. This is not an easy question, but it is doable. We look like we're short of information. If I told you that that was 30 and this was 10, wouldn't you be able to do the question? But all I'm telling you is that this is 40, and that's not enough information to work with. Yet this question is doable. In fact, the answer is going to be 69.7 feet because it's in front of me. I get to see what the answer is. What they don't tell us is how we're going to approach it. So I am going to look at just the top triangle. 18 degrees, that guy. And I don't know who he is, right? And I don't know who he is. And I'm going to call it A. So I'm going to call this distance that I don't know A. What will this distance here that I also don't know, what will that be in terms of A? If the whole thing's 40 and that bit is A, what will this bit be?
40 minus A.
I'm going to take this triangle and I am going to find out what X is in terms of A. Okay, so let's see how that works. From this, won't this be the opposite? And won't this be the adjacent? So far, so good. Which one of the three does opposite and adjacent?
Tangent.
So I know that the tangent of theta is the opposite over the adjacent. I know that the tan of 18 degrees is A over X. So far, so good. So I can now do a little cross multiply. And tan of 18 degrees, right, times X is A. And so won't X be A over the tan of 18 degrees? Are you happy with what we've done so far? Right. Now, I'm going to now build my second right angle triangle, which is going to be the bottom one. And this side is going to be called 40 take away A. and this angle is going to be 14 degrees. And won't this also be x? And from this perspective, won't we call this side the opposite and this side the adjacent? And what I'm now going to do is I'm going to find out what x is in terms of a. So the tangent of theta is the opposite of the adjacent. The tan of 14 degrees is 40 take away a all over x. I do my little cross multiply. The tan of 14 degrees times x is equal to 40 take away a. And won't x be 40 take away a all over the tan of 14 degrees? Now, I know we're trying to find x, and we will eventually find x, but right now, all I know is that x is equal to this weird guy, and isn't x equal to this weird guy? Now, this would not be a question I would ever give you in a test. It is really ugly, and we would not want to do that to any human being. But I want to show you this one because it is such a cool question. The one I'm about to show you after that is much easier. Now, any ideas what I'm going to do?
You could just set them equal to each other and solve for a.
Exactly. Now, once I know what a is, won't I then be able to figure out what x is? Because won't x be whatever this is? So we'll set them equal to each other. So a over the tan of 18 degrees is 40 take away a over the tan of 14 degrees. Because if x is this guy and x is this guy, then aren't these also equal because of that? I know it's ugly, but is what I'm doing makes sense, even although the terms are really messy looking, right? Now, if you want to solve for a, would you agree that you're probably going to have to do some cross multiplying stuff, right? So if I go this way, I have a times the tan of 14 degrees. And if I go the other way, I have 40 take away a times the tan of 18 degrees. And so a times the tan of 14 degrees is 40 times the tan of 18 degrees, take away a times the tan of 18 degrees. What's my next line going to look like? Remember, the goal here is to find a. What do you think I should do next? Any ideas? What should I do to both sides of the equation next to get closer to finding a?
Divide by tan of 14.
You are going to divide, but that would be just a little bit early. I want to do something else before that. But you're on the right tracks, but you've missed a line. There's one more thing to do first. You want this guy and this guy to be together, essentially, right? So how about
So
adding?
add a times tangent,
Yeah.
or 18 degrees.
I agree. Now, since both of those have a in it, right, do you see that divide that you wanted to do? Let's do it now. Shouldn't I divide both sides by this ugly thing? So we now have 40, the tan of 18 degrees, all over the tan of 14 degrees plus the tan of 18 degrees. And that's really why we have calculators. So here it goes. On the top, 40 times the tan of 18. Divided by, put a bracket around it, the tangent of 14 plus, oops, put a bracket, plus the tan of 18. And I get 22 point, what do they want anyway? Nearest foot, let's say 22.6 right now. Now remember the goal was to find A, to find X I should say. So isn't X A over the tan of 18? 22.6 divided by the tangent of 18. So 22.6 divided by the tangent of 18. And there's the answer, 69. Well, I make it 69.6. They have 69.7, but that's probably because they did this to more accuracy than I did, right? They probably called it 22.66 or something, right? But it worked. That is a question from Hades, isn't it? Don't you want to say an easy one now, one that you really would get in the test? But since that's a homework question, I've pretty much cured it, right? Of course, in WebAssign, don't they change one of the numbers at least? So when you do your homework, it's going to be the same as that, but it won't be 40, it'll be 30 feet or 20 feet or something the next time. So the one that does actually work, in other words, one that's doable and not really weird, is this story. There's a building and somebody's here. And there's the ground. And they have a water tower, which I'm just going to have as a big straight line. And the distance from here to here, right? That distance from there to there. You're told that it is 275 feet. And if you do the horizontal line, the angle of elevation to the top is 39 degrees, and the angle of elevation to the bottom is 25 degrees. Now, it looks very similar, doesn't it, to the previous flagpole story, but there's one really good piece of information telling me that makes the job a lot easier. We are being asked to find that distance there. Now, I can't do it in one go, but I can do it in two goes. Can't I find this distance? And then can't I find this distance? And then if I add them together, I've got that guy. Do you like the logic behind that? Now, I'm going to have to call him something. So let's call that guy A and call that B. And the guy we're looking for is going to be X. So won't X just be whatever A is added to whatever B is, right? So that's where we're going. Now, if I focus on the first one, the top one, 275, 39 degrees, and we're going to get A. Let's see if we can speed up some work here. Sine, cosine, or tan, what am I going to use in this story to get A?
Tangent.
Tangents.
Right, so I'm going to skip a line now, and I'm going to say the tan of 39 degrees is A over 275. Are you happy with that? Now, if I do a little cross multiply, won't A be 275 times the tan of 39 degrees? You happy? A times 1 and the other guy goes the other way. And let's find out what that is. 275 times the tangent of 39. And this one is 222.7 feet. So far, so good? Now, if I do the bottom triangle, the one that looks like this one here, the angle is 25, and this guy is 275, and we're calling that guy B. Same kind of question, sine, cosine, or tangent. What am I going to use to get B?
Tangent.
And the tangent of 25 degrees is going to be B over 275. And if you do a little cross multiply, oh, you get the lucky one. 275 times tan of 25 degrees. And again, I'll go to my calculator and see what that is. 275 times the tangent of 25, I get 128.2 feet. And so our answer, the total height of the water tower, is A, 222.7, plus B, 128.2, which gives me, what does that give me? Nothing. I
got 150.9.
Well, there's a 2 there, so 100, 300, I get 350.9,
Oh yeah.
right? And that's right, except they want the answer to the nearest whole number. So to the nearest whole number, it's 351 feet. Would you agree that's a little bit more obvious and the numbers came out pretty quickly? I'm not saying it's an easy question, but is it a lot easier than the horrible bit, right? Are we good to move on then? That's us finished the section. Any questions before I do that? Grace, am I keeping far enough away from the bottom for you now? Or should I be careful?
Yeah, thank you.
Okay, no problem. Well, since that one is over, what is our next one going to deal with? Well, it is, let's put its heading down. It's section 6.4. Sorry, section 6.3. No, it isn't. It is. Oh God, I can't even read my own writing. It's trig functions. Let me check on that, because I think I mislabeled something, but that's me. No, I've done it. Okay. It's trig functions. It's the heading that distracted me because it looks so much like the ones we've already done. And so it's trig functions using right angles, triangles. The heading was so similar to what we've done, I thought, hey, have I just duplicated it? But no, it is different. I'm going to get a lot of notes for what's left to today, so I'm not going to go anywhere near any of the homework questions or what's going to be asked of you, because basically we're going to return to our angle thing here, and we're going to talk about angles in a little bit more detail. Now, can you remember when we started looking at angles, we had an arm that you always placed on the x-axis, and then you had the second guy going up here, right, and we measured the angle, and it, oh, who knows, it's 60 degrees. Remember that? Right. Now, when you start at this, isn't 0 kind of the start, and then you turn anti-clockwise? By the time I got to there, wouldn't it be, what, 180 degrees? And then when I swing back again, would you agree it's back to 360? Right. Now, the shape of the x and y axis splits this two-dimensional space into 4 pieces. 1, 2, 3, 4. These are called the quadrants. So there's the first quadrant. This is called the second quadrant. This is called the third quadrant, and this is called the fourth quadrant. Does that seem reasonable? And so when we're talking about an angle, we're always going to base it, at least to start with, on the x-axis, and then you move things. So I could say to you, well, let's put it on this one. Would you agree that that would be 0? There would be 90 degrees. This would be 180 degrees. Wouldn't this be 270 degrees? And I guess if you get back to where you started, wouldn't it be 360? Isn't it like a clock that would turn anti-clockwise, right? The reverse from what you've used to. So if I said to you, I'm going to draw an angle, I'll call it theta, and it's 32 degrees. And then I'm going to do another angle, and it's 191 degrees. And then I'm going to do another one, and it's 200 degrees. I'm going to do another one, which is 150 degrees. And lastly, I'm going to do one more, and it's 300 degrees. You should be able to tell me which quadrant the second arm would be in. So what quadrant is RL91 and so on? So let's see what that is. Which quadrant is 32 degrees in?
1.
Agreed. In fact, as long as you're in what? 0 to 90 degrees, aren't you in the first quadrant? What quadrant are you in if you're 191 degrees?
3.
3.
Oops, color scheme's going. 3. In fact, if you're in the third quadrant, aren't you any angle between 180 and 270? You agree? What would you be, quadrant would you be in 200 degrees?
3.
What quadrant would you be for 150 degrees?
2.
2. Are you comfortable about knowing which quadrant an angle is in? I know we haven't finished them yet. If you want to be in the second quadrant, aren't you 90 degrees up to 180 degrees? And lastly, wouldn't that one be in the fourth quadrant? And if you're in the fourth quadrant, you're any angle between 270 and 360. Technically speaking, aren't there some angles which are kind of in both quadrants or none? Isn't 90 degrees kind of boundary between the first and the second quadrant, right? So I wouldn't really say it was the first quadrant or the second quadrant. When I think of 90 degrees as a special case, I wouldn't talk about its quadrant because it's special. Isn't 270 another example of a special case? You could say it's in the second, the third or the fourth, but I would just say it's in the boundary, right? It's not really one or the other. Of course, you can make life really sneaky, and I'm about to do that. What quadrant would negative 31 degrees be in?
4.
I like your answer because it's correct. How did you come to that conclusion?
Just go the opposite way.
So you went down here about 31 degrees and you saw it was in the fourth quadrant?
Yeah.
Yeah.
The other way is if you add 360 degrees to it.
Yeah, that's also a good way of looking at it. In fact, adding 360 kind of helps. It might help, for instance, in this one. I mean, you could do moving backwards and that works, but isn't negative 100 degrees also the same as positive 260? Right, if you add 360 to it, don't you get the positive one? And can you remember what name we give to angles where you did that to it? You remember? They had a special name.
Coterminal.
Yeah, coterminal. So you'd probably find a coterminal. And if you did that, isn't 260 in the third quadrant? And for the last one of this type, what quadrant would 510 degrees be in? I see a finger up. You think it's 1? Okay. How would you find out using the coterminal trick? Would you add 360 to that or take away 360?
Subtract
would be-
360.
Okay, let's see what it looks like then. If you take 360 and you subtract, oops, wrong way around. If you take 510 and you subtract 360 from it, do you see you get 150?
Yeah, it's in 2.
It's in 2. But do you see how it's probably a good idea just to do that coterminal trick? Add 360 or take away 360. Are we all good with, if I give you an angle, you know which quadrant it's in, and you know that there are 4 quadrants for it to be in. Of course, every single one of these questions that we've just done could also be in radians, couldn't they? So that's what we're going to do for the last 5 minutes. We're going to look at what quadrant are you in if you're, 3/4 pi and so on. So the same guy that I drew last time, 0 radians. What would 90 degrees be? What would the special case 90 degrees be?
Is
That'd
it
be
half
pi over
pi?
2.
Agreed. What is 180 then?
Pi.
270, which is the one that points down this way.
3 pi over 2.
Have you noticed that you just keep on adding on half pies? And when you get back to the beginning, couldn't that also be considered 2 pi? Right. So first quadrant, second quadrant, third quadrant, fourth quadrant. And we're going to have an angle. And we're going to have a quadrant. I think degrees are much easier to do because aren't you dealing with 30 degrees, 40 degrees? You're dealing with numbers you can do in your head. It gets a little bit messier when you get awkward things. But let's start off with where would 2/3 pi be? What quadrant? 2/3 pi. It's not quite 1, right? It's a little bit shy of 1, isn't it? And I see second quadrant. Would you agree? And won't second quadrant be any angle from a half pi to 1 pi? In the first quadrant, won't you be from 0 to a half pi? Third quadrant will be from pi to essentially 1.5 pi's. That's what 3 halves is. And the last one will be from 3 upon 2. That's 1.5 pi's to 2 pi. Okay. How about, let's put in weird fractions. How about 17/11 pi? Now that one should test you. 17/11. It has to be in one of those quadrants. Where the heck is it?
Third. Quadrant 4, wouldn't it?
Right, quadrant 4. You're correct. Tell me why.
Well, if you subtract 11 from 17, right, you get 6 over 11.
And that's that.
6 is greater than half of 11.
You nailed it. That's how my brain worked. I don't know how others may have a different way of looking at it, but I agree. That's how I would look at it. What would negative pi over 5 be? What quadrant would negative 1/5 pi be? Well done. I
4.
agree. I see 4. You got that one, Caitlin, right? Is that one a little bit easier because it's not too much and you went the wrong way, so it's in the fourth quadrant. If you were going to do it kind of the official way, I'm not sure that's a good way of describing it, wouldn't you just add 2 pi? Like you add 360 and then you'd get a really big answer and you'd say, oh, big answers belong here, right? And that's where it would be. How about what quadrant would 7/3 pi be? Think of coterminal angle. 7/3 pi.
Would be 1.
Okay, tell me why. You're right.
Because there you can get 6 over 3 out of 7 over 3, right? And then you have 1/3 pi left over.
Yeah. So you're going to take 2 pi away, but don't you have to adjust the 2 pi to take the question? So if it's in thirds, won't I call it 6/3 pi, right? But if it was, don't have room for it, but I'll write it down. Suppose someone gave me, I need a number with 9 in it. I need bigger than 18. There. Suppose someone said 21/9 pi. Can you tell that that's bigger than 2 pi, right? So we know it's went round the circle once. But subtracting 29, take away that's a little bit tricky. So couldn't you think of it as taking away 18? And doesn't that leave you with 3/9 pi? And that is that is 1/3. So you see that one would be in the first quadrant, wouldn't it? Now, I just thought you could actually use a calculator, couldn't you? So 29ths take away 2. Let's say we had that to do. So 21/9 take away 2. Horrible decimal is an answer. Agreed? hit the math button, turn it into a fraction. There you go, 1/3 pi. Would that be a little bit easier if you're not comfortable with weird fractions? Right? Just let the calculator do it for you then. That's us for today. Say your last name, and we'll take attendance, and I will hold off.